that's the same as saying 10th root of x. If I gave you x to the 1/12th power, that's the same as saying 12th root of x. Okay, so this number on the bottom always becomes the index, or the number sitting right on top of the radical. And so your next question is going to be, well, what if I have both? What if I have something like x to the 2/3 power? Well, we already know what happens to this number on the bottom, right? So that's going to become your index of your radical. And then the rest of your number, or the rest of your exponent, can pretty much stay the same. So you could just leave it inside, or you can still do this, and you can even put it out there. It's really up to you. I kind of like this one better, but they're both correct, technically. Okay, so that's pretty much how the fractional exponents work. Let's see. So I want to do a couple of does most questions with you. Let me see, 1, 2, 3, 4, 5, and then we'll call it a night. So I'm going to zoom in on this one. And notice that I took screenshots of actual Desmos questions to show you how they work. So the first one says, write the expression in radical form. Okay, so what do they mean by radical form? They want you to turn this into something that looks like this, a radical. Okay, so this is called a radical. Okay, so how could I do that? Well, you notice that you have x to the 5 over 2, right? And I just told you how to interpret that number at the bottom. So this becomes our root. Okay, so if I'm coming over here, I know that this is going to be 2. We don't have to write 2 if it's a square root. You can just leave it. And then the rest of it, we can just write it inside. So that would be my answer to this one. I would write square root of x to the 5th power. Done. Submit. And it should show a little check mark over here that's green. Okay, I can also do this one. So this one's going backwards. So notice this one says write it in exponential form. So that means you're going to take a radical and you're going to transform it into x to some power. So your goal is to figure out, what is this power? What should the exponent be? Well, the main thing I would say to do is to locate your radical. So there's my radical, and you will notice that it is a 5th root, which means your power should be 1/5. So now we definitely know that the denominator of the of the exponent should be 5. So then what is the numerator? What is the top part? Well, that's going to be, let me make this a little smaller. So that's going to be, I keep messing up. So that's going to be this, the 2. So you're going to take that 2 and that's going to go to the top. So your fraction is going to be 2 over 5. So this should be x to the 2 over 5. Yay, submit. Okay, so I'm hoping that it's pretty straightforward to go back and forth between radical form and exponential form. Now let's combine some of these things with what we did last week. So here's a problem, and I want you to notice that we are trying to turn 2 things into one thing. So we have 2 bases, x squared and x to the 4th, and we're trying to turn it into just one exponent. So again, if I write it out a little bit bigger and we see x squared, you don't really see the times, but there's a little multiplication in between. X to the 4/3, right? So this looks like a rule that we did last week. This is the multiplication rule. And if you remember, let me go up a little bit. The multiplication rule pretty much, oh, I think I erased it, dang it. So the oh no, yeah, I did. Sorry. So the multiplication rule pretty much said, when you see multiplication, add the powers together, right? So I'm going to turn this into x to the 2 plus 4/3. And now you're like, oh man, I gotta add fractions. Yes. So let me remind you how we add fractions. So I'm gonna go over here to the side and I'm gonna do 2 plus 4/3. Now, in order to add fractions, it's really helpful if we have both numbers be fractions. Right now, this number doesn't really have a denominator, and I believe we've talked about how you can turn the denominator, how there's a 1 there, if we see nothing. So if there's a denominator already, leave it alone. If there isn't one, go ahead and throw in a 1. And then here's the trick. You probably remember when you were younger, the teacher talked to you about this concept called common denominator. Okay, so you need the denominators to be common. Right now we have a 1, we have a 3. So we can't do anything until they're both the same number. So you should ask yourself, is there a way that you can turn the number 1 into 3? And you're like, oh yeah, I could just multiply both things by 3. And that would give us 6/3 plus 4/3. And now that both of these are the same, you're good to go. You can add. So the denominator is going to be 3 because it's the common denominator. And then in the top, we do 6 plus 4, so 10. So that is our magic power. So another way to say this would be x squared times x to the 4/3 would be x to the 10/3. So be careful, don't put x to the 10/3 in here. The question's asking for the value of a. See how it says the value of a? So they just want this. They just want the power. So just put 10 divided by 3. Done. Okay, let's do another. So you'll notice here, this set is being divided. So this is a very obvious division rule. Right? And what did the division rule say? It said if you have x to the a power divided by x to the b power, you would subtract. So let's go ahead and down here. So we have x to the 1/2 divided by x to the 1/6. So we're going to take our powers and we are going to subtract. So we have 1/2 minus 1/6. So again, we run into the same problem from last time. Down here, our denominators are not the same, so we cannot subtract them yet. So ask ourselves, is there a way to turn 2 into 6? Oh yeah, I can just multiply both by 3. So that'll give me x to the 3/6 minus 1/6, which is x to the 2/6. And you can even go one step further and reduce this a little bit more. So if you took this 2/6, you can reduce that to 1/3. So it's asking, what is the value of a? 1/3. Okay, and also keep in mind from earlier that we can turn this into cube root of x. Okay, but they're just asking for the variable. So 1/3 is correct, but also keep in mind that those are equivalent. Okay, and lastly, this is a case where we see the power rule involved. Remember, the power rule said x to the a power to the b power. So see how there's two exponents, one is outside of the other. So what did we do in this case? We multiplied. So I'm going to multiply, and here's the good news. Multiplication, the rules for multiplying are very, very straightforward compared to the rules for adding and subtracting. With fractions, they don't really care if the denominators are common. So just keep this in mind. If you are multiplying or dividing, you do not need common denominator. You don't need it. So then you're thinking, well, what do you do then? So we're going to take these and we're going to make this x to the 5/6 times 1/4. And this is going to be x to the, just multiply straight across. What's 5 times 1? 5. What is 6 times 4? 24. And I think that's as far as you can go. So that would be the power. And just again to practice, if you wanted to turn this into a radical, you can do this. The 24th root, this number is the root of x to the 5th. And that should be enough to, I believe, get you going on your Desmos. If you have any other questions, I'll be in office hours.